All right, so we are entering the last phase of this lecture or this course. As we start at the beginning, we mentioned that not only the computing is important, but also the distributed computing, right? Because parallel computing is more about performance. But nowadays, we require computation spread across machines or even around the world because we want to share information, share resources, and many other purpose, right? And all those software or application running across machines. So those type of computation are called distributed computing, right? So it's a even more general way of doing computation across machines. And its purpose is not just performance, but also many other reasons. Especially we see the rise of cloud computing and IoT, right? Internet of Things. All those kinds of technology are driven by or developed by distributed computing. So at the end of this class, I would like to also talk about distributed computing. And specifically over the past maybe 5 to 10 years, we see the two biggest driver for distributed computing are from big data and AI. And as we will know, we will explain why those application or those application domain are actually highly depends on distributed computing and how those computation can be different from parallel computation. Okay, so for this lecture, we will talk about big data, and the final lecture of this course will talk about AI. Okay. Okay, so I guess some of you have learned what is big data from other courses. So for this course, we will also give a overview, right, about what is big data. And for this course, of course, we are more focused on how to provide or enable distributed computing for big data. So specifically, we will introduce a system called Hadoop, which is very famous distributed computing framework for data processing. And although maybe today not many people are using Hadoop today, but the design concept of Hadoop can be seen from many distributed systems, especially for data processing system in the more modern frameworks or distributed computing systems. So I think it's very important for you to at least have an idea what is the design and how to enable distributed computing in Hadoop. And we will also introduce Spark, which is an example of how to extend the idea of Hadoop to another level. So enable to support more diverse and even more faster computing for data processing. Okay. All right, and all those tools or platform are very well known, and so you can still find those software, and they are open source software, so you can still find them on some of the cloud platform, or you can simply try to install it on your own cluster or computer um, for for to use those platforms. So we will also arrange a lab and using cloud to that you has experience to use Hadoop and see and to understand how to do the coding on Hadoop. Okay. All right. So there are still a lot to talk about for distributed computing. So let's start with the introduction of big data. Okay. Okay, so I think pretty much right. Most of you have heard about what is big data already, right? Because it's a very buzzing word in the world before AI. And actually, big data is a stepstone for AI. So it has been very popular in the past, and today it also become a very essential step to achieve AI solutions. Okay, and the reason we people start talking about big data is because the volume of the data has grown significantly over the past decades, and you can see the reason is you have more diverse source that can generate those data, and especially like the emerging technology like sensors and internet of things. So um, the those machines and sensors can generate data in an unprecedented speed that cannot be matched from just human. Okay, so there are a lot more data get generated over the past decades. Okay, and most of them is actually not generated by human, but by the sensor or the machines. Okay. So, like I said, the reason we see this surge of data volume is because of the source, right? You have more diverse source, not just from some regular documents or some human generated data, but even more from those sensors, mobile device, and also because of the social network, right? So people keep generating those messages on social network or social network applications, and so through over the time, then the amount of data can be generated and aggregated in a very fast speed. Okay? And as a matter of fact, actually, big data or the problem of data volume has long is a long existing problem, but in the past, you probably only care about this problem if you are working on some scientific computing problem, because in the past those scientific device like telescope, uh, they can generate a huge amount of data from those scientific simulation or instruments. That's why people build supercomputers, right? In the past, those national labs are are the organization to conduct those scientific computing, and the amount of data generated by those applications is also in a very large scale. Say maybe just a single file maybe takes about a couple of terabytes, or today you could have a file with 1 petaflops, petabytes data size. Okay, just a single file. So imagine how could you handle such a data volume, right? It cannot be stored on a single device, a single server, or cannot even handle by the regular or the normal file system, because they are not designed to handle such a volume of data. So it's a long existing problem actually, but of course in the past, not many people, right, especially in the industry, uh, they don't encounter those kind of problem. They probably not rely on scientific computing. But today, you can have collect data very easily, and you know, as we were introduced, people start to have the concept of a big data. So it become a general problem in the industry as well, or in for any people they may encounter the data volume problem. So that's why it become even more important in today's world. Okay, and it's become a very common and common same problem for everyone and in every probably application domain. Okay, and so that's what I said, right? So of course, no, it's actually in some sense it's easy to collect data today. But the point is, you would like to store the data, right? If you generate it and you throw away, then you will still not accumulate the data. But because of the concept of big data, people start realize how important is the data. Okay, so people will try to not just generate it, even try to purposely collect those data. Then, of course, it's more likely you have a larger volume of data to analyze. Okay, so it's all because of the people start to realize how valuable it is for how much value you can get from those data. Okay, and we will, of course, we have seen the example around us, and I will give you a couple of example, right, to show what is the value of a data. Okay, so the value of data is, again, this is not a new concept. Way before, people already proposed the idea of data to wisdom. Okay, and so they propose a pyramid of DIKW. Okay, and you can see each letter stands for a term, right? Data means D means data, right? Referring to those symbols, those signs, those raw data, right? Some data, that any data, any digitalized data, and it may not be interpreted and understand by the human, but still they are data. Okay, so of course the volume of the data usually is the will be pretty huge, right? And you have to process before you can actually use those data. So the next step is people usually do is to convert data into information, right? So we all know information means that it has some meaning to the data, right? And usually means the data is able to describe something, right? It becomes a description, so it becomes some information like the direction or a sign or a color, something like that, right? But they are just pieces of information, right? They are not connected, or they may be they are just piece of information only. Okay? So in order to utilize those information, right, then people have to further uh, analyze or process the information into knowledge, right? So knowledge means something that's digest, organized, right, with some purpose. So like our lecture, right? The course we are giving to you, those are knowledge, right? The reason you come to class is to learn knowledge. Okay. So sometimes those knowledge can even explain explain why or how people do things. Okay. So you even have some reasoning behind it. Okay. But like the real world, right? After you take the class, um, you learn the knowledge, but you still need to figure out how to utilize the knowledge, right, in order to solve the problem in the real world, right, or in your work, right, in your work or in your daily life, right? That become wisdom. Okay. So wisdom means usually means it's an intelligence decision, right? Which can create values or achieve some goal or achieve some purpose. Okay. So knowledge is not enough, right? So maybe you can have a very high score in the class, but still doesn't mean you are able to solve the problem you encounter in your work, right? Or so at the end, what people really want usually is wisdom. Okay, and the wisdom is exactly um, the term AI referring to, right, today. So you can see that we say big data is a base for AI because the wisdom, as at least in the digital world, is coming from data. And to process data, to generate information or even knowledge, this task is what we call the big data, right? So big data is um, actually try to process, store, and analyze a huge volume of data in order to extract the knowledge or the information. But at the end, we still need to achieve wisdom and make intelligent decision. So that difficult task is AI, right? So after people figure out how to solve the big data problem, then we in the step that try to solve the AI problem. Okay, so we try to convert the knowledge into wisdom. Okay, all right. Just like automobile, right? We know like data is just we know the car we will install many sensors, right? So we collect lots of data and signal that can represent the environment or the state of the car, right? And then we have to convert those signal into information, like we see a sign on the roadside, or we know the pressure for our tire, or we know the direction sign from other car example. Those are the information, and the knowledge is probably we need to know the rule for driving, right? So we have to be able to control our car in order to follow those rules. And the wisdom is how exactly can we drive the car, right? By the computers, in order to follow the rule and make sure the driving is safe, right? So you can see that what we are doing over the past several decades is actually exactly doing the same thing. Just that I think we are pretty close. We still not achieved it yet, right? For automobile driving, as example, we are getting close to the final goal. But still, today we still don't see many automobile cars on the road yet, at least not for everyone. But maybe that will become a reality sometime in the future. Okay, so that's a very good example how people keep trying to explore the power of computation and data in order to achieve the end goal. Okay, all right. So you can see that's a very long road, and we are just in the process. Okay. All right. And so, of course, for this lecture, for the first part, right, we are focusing on big data. So for big data, usually the main challenge is to how to collect the data and how we could capable of handling those data. Okay. So you can see that for big data paradigm, it's as simple as 3 steps. The first is to tap into the diverse data set so that we can collect more data, right, from more sources, and then try to analyze or fusion those data together in order to explore some relationship. And for big data, usually the method to analyze those data are more simple because there are many challenge we need to overcome, as I will let you know in the next slides. So it's more about how we could capable of handling the data, not really about, at least not that much about what algorithm to use in order to analyze the data. Okay, but at the end, also we don't have deep learning neural network, those sorts of solution here. But still, for big data, it still want to achieve value. Okay, so whatever your big data solution is, at the end, it still should deliver some result of making some intelligent decision or business decision in order to get the value or get the money, right, for the industry. Okay. Okay. So why is big data, if you put it in a story, right? A very famous story is called The Tales of Beers and Diapers. Okay. So beers and diapers seems to be unrelated, right? Unrelated items in the world when you go to the supermarkets, right? However, surprisingly, for the supermarket, those supermarket chain, when they try to analyze their data, they find out actually there is a very strong correlation between the two. Of course, it may not be true for any country or in any regions or for any places, but at least it seems like in the U.S. or it is true. Okay, and the reason, so how they get this correlation? Actually, it's quite simple, right? All they need to do is to collect the receipt from the customers and then check whether a customer try to buy those two things together. What's the probability, right? Those two items are they are purchased at the same time, and it seems like the result shows the probability is higher than many other items together. Okay, so it's just a pure statistic uh, analysis on the receipts on the data. Okay, so what that indicate is for those supermarkets, an important decision to make is how to place their item in their shop, right? If you put two items, highly correlated items, in a near location, then the customer may have a better desire to buy two things at the same time, right? Without trying to looking for the other item. So with a good placement, somehow it could effectively increase their sales, okay, and their profits at the end. Okay, so it's an important question for them, and the result of beer and diapers indicate that's a good business decision. Okay, and so it become a successful solution for the supermarkets. And so this is the power of a big data, because you can see this, you probably could only see this coming if you collect enough of number a larger number of data, okay, and do this simple statistic analysis, then you can get this useful results. So that's the concept, right? The idea of big data. And on the other hand, the big data solution also usually means that it provides a decision, tells you, how, what is the right decision, but it doesn't explain, why is it, right? What's the reason behind it? For example, why beers and diapers are highly correlated. There could be two sides of a story. Okay, if you look at in the good way, it's probably because the parents has a newborn child, so they are very happy. They invite their neighbors to have a party in their home, right? So they need to buy beers. Okay. On the other hand, if you look at the dark side, it's probably because in the past, the father usually can hang out with his friend during the weekend and go out to have fun, but now you have the children to take care. So the father has to stay at home, right? And all he can do is probably sit on the couch and watch TV and drink beers. So that's why he needs beers, and he need to buy diapers as well. Okay, so the statistic doesn't tell you anything about that, right? So we don't know why or whether this decision is reasonable or not. It's pretty hard to judge instead of just trust the statistical results. Okay, but this approach could be quite easy, right? And it could be correct and useful. All you need is to collect enough of data, right, and perform some statistic, then you can get a very good results. Okay, so it's a very classic example for big data. Okay, it represents what it means and what's the risk behind big data. Okay. All right. So like we mentioned, right, big data is actually just a stepstone to our final goal, to reach intelligence. So we finally reach this step because of the use of deep learning, right? So deep learning is maybe the final bridge to our goal, because deep learning, as is a very powerful tool, right? It is able to convert the data, right, to intelligence, because it can has the ability to make the correct decision, and that is what we call intelligence, right? And the reason, and as you know, that deep learning specifically, it's a learning method, and is a learning method based on uh, a technique called the neural network, right? So you use the neural network architecture to learn the decision from the data. Okay, and why deep learning is so popular, right? And also it's the right tool to solve our problem, is because it actually can be proven that a neural network architecture, a neural network model, is a learning method that is capable of describing any function in the world. So it's a universal approximation theory behind it. Means that because any decision, you can think it as a function, right? The input of the function is some data or information, and the output of the function is the answer or the intelligent, the correct results. So deep learning become the tool that can convert the data to the decision. Okay, and if you have a universal approximation function, that means for any problem, right, you are able to find a precise function that can achieve an accurate mapping between the input and output. So you can get a result with very accurate results, right? Um, so um, so this is a very important property for a neural network model, okay, which is not true for many other learning methods. So there's a limit to their method. There's some function, some problem, they just cannot find they are limited by their method, so they cannot provide the accurate mapping between the output and the input. But that's not the case for neural network. Okay, but of course, there's a downside for this method, right? And of course, we will talk a lot more in the last lecture of this class when we talk about AI. But as you know, in order to make the model accurate, you have to train by a huge amount of data, right? The result is driven by the data. So first of all, you have to collect enough size of a data and make sure the quality of the data is good. And furthermore, you need computation power. That's where the distributed and parallel computation comes in, right? Because if you have more data, also it means you need more computing power to process the data. Okay, um, but since we have some solution for the big data already, so as you can see, as we collect more data, we can get better performance or more accurate results from deep learning model. Okay, that's why we are we today this is the general way to achieve AI, and so that's where we are standing at right now. Okay. Okay. So you can see actually AI is more complicated than you think. It's not just about how to design the neural network model or what the algorithm we need to propose. to to achieve some intelligent decision. It's actually a long process from how you collect the data, how you pre-processing the data, how you analyze and clean the data, and eventually how you find the proper or the efficient neural network model, and how you could train it uh, correctly in order to uh, get the accurate result at the end. So it's a very long process for processing those data. Okay. So in order to achieve AI, you can see we actually require many expertise, and usually at the beginning it's more about big data, right? And toward the end it's more about AI. Okay, and you can see at the lowest level, usually we have data engineer. Okay, so those data engineer, the responsibility of data engineer is to build a system and manage, operate that system for collecting data and to process the data, right? And then you have the data scientist. That's the people that they have more science background, right? They are better in algorithm, so they will know how to analyze the data on top of the system and the data provided by the data engineer. Okay, and after the data scientist analyze the data, then the analysis result will use to drive the AI solution. Okay, you have AI engineer and AI scientist to further, uh, you know, build an AI solution or products based on those knowledge or the those information. Okay. All right. So you can see that's why if you try to look for a job, you might think those positions called the data engineer, data scientist, AI engineer, or AI scientist. Now, each position actually referring to they require a different set of skills and to handle a different problem. And they are all required if you want to provide a AI solution at the end. Okay? And you can see for each position, usually for example, for data engineer, it needs to, as we mentioned, to manage the data and build the architecture for the data, right? So they need to figure out how to collect data, how to store data, and the tool they use is also different from other positions, right? So like the Hadoop system we introduced, it is a very commonly see software or platform for data engineer. Okay? And for data scientists, it's more about algorithm, right? So they need to be familiar with machine learning, right? Or data analytics. And they usually use some of the tools like um, query, SQL query, or some machine learning library in order to analyze those data. Okay, and so an AI I not put here, but as you probably heard, if you need to become an AI scientist, you have to know some of the AI framework like TensorFlow or PyTorch, right? And you have to be familiar with the AI or the neural network architecture, right? So you know how to train the model and how to maybe fine tune the model architecture. Okay. And finally, you have the AI scientist, right? The AI, I should say, the AI engineer. Okay, so the AI engineer means you need to put your AI model to the field, right? For example, if you try to build an AI solution, try to diagnose value by image, right? So you have to first of all figure out where should I put my camera, right? And how can I feed the data from the camera to my model training platform, or how can I deploy my model to the sensor, right, or the device in order to do the detection, right? So all those things are, require engineering. Okay, so the people work on that uh, usually they are called the AI engineer. Okay, so you can see the scientist is more about data and the algorithm, and the engineer is more about the end-to-end solution, the software, and the how to manage, how to deploy the solution in the real world. Okay. All right, so you can see this is also a long process, and in order to be successful, usually a company need to have a solid foundation in big data, and then they are capable to explore the solution of AI. And so that's why it's not as easy as saying that um, to provide AI solution in a company or in a factory. Actually, you have to build from the ground. Okay. Okay. So, but that's what happened in the world nowadays, and that's why you can see people, all the companies, industry are looking for talent for AI and big data. Okay. All right, so that's the whole story, and now we just come back to big data. So what exactly is the problem for big data? And in the past, right, probably 16 years ago, a big data may be a problem like shown here, just to move a 5 megabytes of data from one place to another. Okay, because as you can see, um, at that time, to store a 5 megabytes of data, it might require a huge machine like shown over here to store that kind of amount of data. It's so big that if you want to transfer from one place to another, you even have to use the flight. Okay, it might seem very ridiculous, right? But what about now, right? Today, what the problem we face is, say, if you want to transmit 100 petabytes of data, and how could you do that? You ship it by truck. Probably not much better than the 60 years ago, right? Of course, 100 petabytes seems huge for you right now, right? But still, it's just some volume of data. And the method we use, even though we have internet, we have high-speed network, but still, if you reach the volume of 100 petabytes, actually the most efficient and most cost-effective way to do that, to transfer the data, is by truck or by plane, like before. Okay, and it is not a joke. Actually, AWS is one of the most famous cloud service, right, in the world. It provides all kinds of services, right? And one of the service is to ship your data by plan and delivery. Okay, so what happened is, if you order the service, they will send you a box and ask you to put your hard drive into the box and then ship it up to the data center or to another location. And it turns out to be an efficient way because if you need to transfer a huge amount of data, you might still takes very, very long time if you're sending through the internet. And also the cost for sending those data through internet sometimes is very expensive. On the other hand, if you deliver by a truck and flight, you might just reach your decision within a couple of hours or a day. Okay, so it turns out we still have to solve in the old solution. Okay, so from this you can see that we always have this big data problem. Okay, and so the problem of big data sometimes actually defined by um, the, the current technology. Okay, so as you can see, what's the more formal definition of big data problem? Okay, you can see the formal definition is to try to extract values from some immense large amount of volume that cannot be handled beyond what we previously possible. So it's all depends on what tools you have at hand, right? And if you cannot solve it by your existing solution for processing the data, then it becomes a big data problem. Okay? On the other hand, right? Uh, if you just have a huge amount of data, doesn't really means it is a big data problem, right? Because the computation power and the storage space for a single server, today is also quite powerful, right? So maybe a 10 terabytes of data processing problem, it may be a big data problem, 10 or 20 years ago, but today maybe it is not a problem at all, right? You can use classic or traditional tools to solve that. Then it is not a big data problem. Okay, so it all depends on what tool you use, what tools that require to process the data. Okay. Well, that's one way to look at what is big data, and we will provide you more view or more angle to define what is big data, big data. Okay, and of course we will explain what is the tool that is new and designed for big data, comparing to what is the traditional tool. Okay, how can you tell what is traditional tool, what is the new tool from big data? We will explain that throughout this lecture. Okay, all right. That's the general definition for big data, and um, why how also the big data usually is defined by several V's. Okay, so those V's, as you can see, the most important one is value. So that's the goal, right? Everything about the solution is to deliver value. Okay, and for the rest of the V's, they are challenges. Okay, and also because of those challenges, that's why the traditional tool may not be able to handle the task. Okay, so there could be many challenges, and some of the most famous challenges from big data that cannot be handled from the traditional tool is the volume, the variety, the velocity, and the veracity. Okay, and so you can see that if we could use some new tool and overcome those challenges, then it provide us the ability to process or analyze the data in a way that can never be done before. That is why it is possible to explore new value, right? So that's the all the reason behind big data. Okay. Okay, so let's just look at those challenges. Okay, the first one is called the volume. Okay, that referring to the size of the data, right? The most trivial one and usually the first challenge we encounter when we try to handle data, right? And as we said at the beginning, you can see how much the size of the data has grown over the years. So it become a problem, right? Um, as example, if you have only one server, one machine, or one hard drive, the largest data you can store on that hard drive is probably just 4 terabytes. So if you have a data source that can provide a data up to 10 terabytes, then you could not even store it, right? So that's the problem created by volume. Okay, and more so, the for those data you collected, is unlike the data we try to process in the past. The data we try to process today usually are they are unstructured. Okay, so unstructured means that they don't have a fixed schema or some fixed format to store those data. So that brings us the second challenge, variety. Okay, so the varieties comes from how we collect the data, right? Because basically the reason we can collect huge amount of data today is because we tape into a variety of data sources, and each data source may provide their data or generate their data in different format, different semantics, or even different data structures, right? So you have a very complex problem that you need to try to use a same software or a same solution on a variety of data. So that brings a huge challenge. And specifically, as we will talk about this more in more detail, for example, in the past, people usually rely on database for data analysis because it's very simple and very useful. And as you know, the performance for database is very good. The query usually can be processed in just a few milliseconds, right? However, for database, it has a schema, right? Data needs to fit into the data structure, right? The table schema. So it's hard for people to store any kinds of a data into a database. Um, it's become even impossible to fit into a single table, right? Because all those data has different semantics and schema. Okay, so that's why the traditional tool cannot solve this problem. Okay, and the tool like we will introduce, like Hadoop and Spark, you will see they can process on any data that is stored on file system or storage system in a binary data format. Okay, um, so we need a general solution, general software that can handle all kinds of data. Okay, all right. So that's why a tool like Hadoop and Spark are developed. Okay, instead of using the traditional tool like database. Okay, and without this, it's hard to accumulate your data. It's hard to explore new value from the data. Okay. All right. The third challenge is velocity. Okay. So velocity usually referring to streaming data, right? So as you know, for streaming data, what happened is, the data size pretty small, but the data just keep coming, right? And you have to analyze or process the data within a limited of time. So that means you have to not only need to process a huge amount of data, but also within the time constraint. So that's even a harder problem to solve, right? And as a matter of fact, velocity usually is the biggest challenge now, okay? Because the emergence of uh, Internet of Things and mobile device and social networks, all those applications, the data generated from all those applications is streaming data, right? So all of them require velocity. Okay. All right. So how to achieve better velocity? Of course, one straightforward way is to use more machines, right? So you can have more computing power, and so it's more possible to process data within a limited time. Okay? And finally is the veracity. Okay, veracity is still kind of an unknown challenge now because what veracity means that the data cannot be fully trusted. It's not always accurate. Um, the reason is because in the past, when we use database or traditional way to analyze the data, usually we try to clean up the data first, right? So if there's some inaccurate result or inaccurate data, then we will just filter it out. But what that results in is you will lose some of the information, right? You will lose some of the data volume. So for big data, we don't want to throw out data in, for any reason. So as a result, you might have some data that is inaccurate, and it's especially common if you collect data from some sensor devices, right? So it's very normal you have some abnormal signal or miss or packet drop when you try to collect the data. So for big data, you need to overcome that. Okay, and more so, some extent, extreme extent, they even try to explore value out of those data that's supposed to throw away. So that kind of research or that kind of approach is what we call the dark data. So dark data, it means you try to intend to find value from those anomaly. Okay, so how to analyze those data become it is more depends on the algorithm. So that's why even today probably it's hard to find some general tools to solve this. All we can do is to aware that the data may be inaccurate. And for some solution like AI, or from I should say for neural network, for neural networks, sometimes it actually requires some noise, right, in order to get a good result. So the method also fit pretty well for big data because sometimes we need noise to jump out some local optimal. So you can see, neural network it could be part of it. Actually, those veracity problem become advantage, or it will help us. Sometimes we need this in order to get a better results. Okay. All right. So that's the brief introduction about big data, and then we will talk about it more in the next lecture. Okay. Okay. Any questions?